So good morning, everyone. This is day 150. We're going to talk about graphing exponential functions. Okay, the first types of graphs that I taught you, and so you're going to learn a bunch of graphs in math all the way through when you're done with integrated math 3 and beyond. The first one I taught you was linear, okay? Okay, so the first one I taught you was linear. The second one I taught you, that I'm teaching you today, is going to deal with exponential equations, and it's going to look like this. And this is called an exponential equation, and specifically it's called an exponential growth. Does that make sense, everyone? So, and the way you know it's exponential growth, because from left to right, you see how it's growing quickly? You see that? Okay. So, for example, like the example I give you, if you ingest a virus or bacteria, at first there's only going to be one molecule of it in your system, but it's going to double every 5 minutes, okay? And you might get sick after 3 days, right? Because at one point it's going to double so much that it's going to start affecting you, right? So that's exponential growth. The last one is called exponential decay. And exponential decay from left to right drops very quickly. Okay, it drops very quickly from left to right, and then it drops so slowly at the end that you can't even tell that it's decreasing. This is called exponential decay. Okay, so these are very relevant to science. Very, very relevant to science. And like exponential decay, like carbon dating. Anyone ever hear of carbon dating? Like there's an old dinosaur bone. They're like, how do we all know how old it is? They use carbon dating. Raise your hand if you've heard of that before. A few of you? Okay. So what they do is they know that so much carbon is in a certain fossil. And so over time the carbon decomposes, and then they'll know that the particles have an exponential decay, and they're able to tell how old something is by that. Okay. Cool. So here we go. Next one. Vocabulary. End behavior is what happens at the end. So if you're noticing here, the end behavior exponential growth, you see how it goes up forever? You all see that? And then the end behavior here keeps going down, but it slows down forever. It kind of gets closer to 0. You see that? Here, let me give you an example of why this happens. Okay, so here we go. Let's do some quick math here. What's half of 4?
2.
What's half of 2?
1.
What's half of 1?
0.5.
1/2. What's half of 1/2?
0.25.
1/4. Do it as fraction, please. Okay. What's half of 1/4?
1/8.
Good. What's half of 1/8?
1/16.
What's half of 1/16?
1/32.
Good. Okay. Y'all see that? Now I got a question for you. Will my answer ever get to 0?
No.
No. Why not?
Because 0 is not the half of anything.
Yeah, 0 is not the half of anything. Good point, right? Isn't 1/32 really close to 0, though? Would you all agree with that?
Yes.
Good. Is it closer to 0 than 1/16?
Yes.
How much closer? A half, right? Does that make sense? So what's halfway closer to 0 than 1/32?
1/64.
Good. Are you all getting that? Okay, good. So this is called an asymptote when we get really close to a number. So there you go, 1/64. There's this word called asymptote. Okay, let's all say asymptote.
Asymptote.
Good. All right. Well done. Asymptote, right? And I want you to write this word down in your notes. Okay. Asymptote is the number the graph gets closer to but never touches. Okay. Or it does not cross it. So here we go. So the goal for today is I'm going to teach you how to graph. Okay, I'm going to show you a couple of these. We're going to talk about the end behavior. So the directions here at the top say the following. Graph each exponential function. Oh, sorry about that. Graph each exponential function and after graphing, identify A, B, and the y-intercept and the end behavior of the graph. Okay, so we got f of x is equal to 3 times 4 to the x power. So the first thing you want to do is we want to identify A and B. So in this case, A is equal to 3, B is equal to 4. And B, remember, is our ratio, right? This thing's going to go up by 4. 4 times 4 is? 16 times 4 is? 64. 64 times 4 is 256, okay? You see how it gets bigger? Okay? So it goes pretty quickly. Exponential growth. Very quick growth, okay? The next thing, step 2, create a table of values using the domain 0 or -2, -1, 0, 1, and 2. Okay? So you want to create a table of values, and this is a good strategy to use whenever you graph anything. And we want to start by inputting -2 into here. So we start with the exponent. What's 4 to the -2? What's 4 to the -2? Let's see if you remember how to do this from middle school. 4 to the -2. What's 4 to the second power? No, 4 to the second power is? 16. Good. So I want to show you 4 to the -2 is actually 1/16, okay? You see that? So when you have a negative power, you're going to flip it, and then you're going to put the answer at the denominator, okay? Try this again. Ready? What's 4? Oh. And then we have to multiply. 1/16 times 3 is going to be, we're going to put 3/16 right here. So that is the output of the function here. Let's try this again. Ready? What's 4 to the -1st?
1/4.
Good. 1/4. Did y'all get that? Okay. And then 1/4 times 3 is going to be 3/4. Okay. And I keep going here. Let's see. 4 to the 0 power. What's 4 to the 0?
4.
1. Good job. This class on it. 4 to the 1. What's 4 times 3? Or 1 times 3?
3.
3. Excellent. And then 4 to the 1st, of course, is 4. 4 times 3 is 12. And then 2 squared is 16. 16 times 3 is 48. Okay? So you see how it's exponentially growing here quickly? Y'all see that? Okay, now we're going to take these as ordered pairs, and we're going to graph them on our graph as points. And we're going to graph them like so, and then we're going to draw a line across. And at that point, we're done. Now, you see the y-intercept here is at 0, 3, so this is our y-intercept, 0, 3. And I'll mark that off with red. That's our y-intercept. You'll also notice that the end behavior is going up forever, okay? So we say that it's infinitely increasing as x gets bigger, okay? Y is infinitely increasing. Y'all see that? Okay, questions on number 1. Okay, I'm going to go to number 2 now. Number 2, one more time. Number 2, we have f of x is equal to 2 times 2 to the x, okay? So the first thing I want to do is identify a and b. A is 2, and b is 2. Okay, and then I'm going to do step 2, make a table of values using the domain. So we got x and y, and we're going to start with -2, -1, 0, 1, and 2, and we're going to start inputting our values. Okay, -2. What's 2 to the -2? 1/4. Good. What's 1/4 times 2? A half. Excellent, right? Again, 2 to the -2 is 1/4. 1/4 times 2 is 1/2. So I put that here. Okay, let's do it again. 2 to the -1 is 1/2 times 2 is 1. Excellent. Okay. 2 to the 0 is 1. 1 times 2 is 2. We got that right here. 2 to the 1 is 2. 2 times 2 is 4. And then 2 squared is 4 times 2 is 8. Again, it's exponentially growing. You see that? It's doubling every time, right? Just like your cold, your bacteria double every so many minutes. So now we're going to put this into our graph as points. And again, it's going up infinitely. As x gets larger, the graph is infinitely increasing. Okay? Does that make sense, everyone? Awesome. Okay, so yesterday I didn't get to work with you. So let's have, and I know that the 4s usually go on Thursday, but since 4s didn't get to participate yet this week, let's have our 4s. 4s, 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 4s. There's no 4 there, so let's have Jonathan work in the back as a 4 today. 4, 4, 4, 4. I'd like you to explain your best on how I graph this exponential function, okay? Ready, set, and go. I'd like to give you some good notes. So we're not going to have you write this down. You're going to do number 3 together with me. So number 3, let's start by having you write down the original function right here. F of x is equal to 2 times 3 to the x. Okay, this is going to be our nice one we're going to put in our notes. That way you have it for a test, okay? Again, you're writing down what's highlighted. Everyone's doing this right now. Everyone is. This is, you all have to participate now. You all. Boys and girls, you need to participate. Okay? So here we go. Step 1, all my 4s back again. 4s, today's your day. 4s, tell your group what A and B are. Step 1, identify A and B. Okay. What's A equal to, everyone?
2,
B?
3.
Okay, good. Step 2, 4s. Again, what do we have to do on step 2, 4s?
Make a table.
Okay, good. So we're going to make a table. What are my domain values or my inputs?
-2, -1, 0, 1, 2.
Good. Okay. Here we go. Let's put -2 in for x. All eyes up here. Okay, what's 3 to the -2? 3 to the -2? 1/9. Good. What's 1/9 times 2? 2/9. Good. Okay, next one. -1. What's 3 to the -1? 1/3. What's 1/3 times 2? 2/3. That's correct. Okay? Those are the harder ones, right? Here we go, 0. What's 3 to the 0? 1 times 2? 2. Good. Here we go, 1. So why isn't it playing here? 1. What's 2 to the 1, or 3 to the 1?
3.
3 times 2? 6. Good. Okay, and then the last one, 3 squared? 9 times 2? 18. Does anyone have questions on any of these outputs that we just calculated? You feel good? Yeah, Braden.
It's 2/9, right?
2/9, yeah. 2/9. This y, you see how this y is sticking down? Sorry. My bad. Okay? Cool. Now this is what I'd like you to do. We're all going to graph this. I know I just want you to make a rough sketch of an x and y axis, and then I want you to plot these points, okay? So everyone's making a rough sketch of the x and y axis, but still nice enough so you can use these for notes, right? Because you get to use notes. Okay, so after you plot them, they should look like this. Exponential growth or decay, everyone? Good. What is my y-intercept? What's the y-intercept, everyone? 0, 2. Or what's the value of y? It's 2, right? So here's a secret for the y-intercept. Look at where x is 0. What's y equal to when x is 0? 2. Okay. What's the end behavior? Is it infinitely decreasing, or is it going toward an asymptote? Does the graph go up infinitely, or does it decay toward an asymptote?
Infinitely.
Okay, good. Does that make sense? Okay, cool. I think I want you to do one more. Can you handle one more, and then we'll be done? Okay, good. So if you could do this next one by yourself, meaning by yourselves in your groups, then you're good. So start off by writing down the equation or the function, and then you're going to go through all the steps. You could use your group. And, oh, by the way, I'm going to go back to the last one really quick. What can you do to check your work always? What have I been teaching all year with that app? What app? Desmos, right? So I want you to be familiar with it. Now, Desmos is a helper, not a doer. So don't get used to it doing all the work for you. I want it to help you, okay? So again, you could put the original problem and then it'll show you the graph, okay? We're going to go to the next one. Here we go. Okay, so you're all working on this. I'm going to pause the video here. I need you to work this out. F of x is equal to 6 times 3 to the x power, and you're going to graph this. And you can get some help with your groups. Okay, go. Okay, what's A and B, everyone?
6.
Good. So you should have your XY table look like this. 6/9, 6/3, which is going to be 2, 6, 18, and then, of course, 54. Okay? And then your graph, of course, when you plot it, should look like this. And that's it. Exponential growth or decay, everyone? Good. is the end behavior infinitely increase as x increases, or does it get closer to an asymptote? Good, and exponentially increases. Good. What is the y-intercept? Good. That's it. Okay. Now I want to just explain. You know how I talked to you about end behavior? What if your graph looked like this? Okay. Just really quick for 15 seconds more. This blue line, exponential growth or decay? Good. Is the end behavior increase infinitely, or does it get closer to an asymptote? Good. What is the asymptote? Okay. Look up here. The asymptote is this green line. It's getting closer and closer to 0, or y is equal to 0. Right? Remember earlier I said what's half of 2?
1.
Half of 1?
1 half.
Well, half of 1 half? 1 half of 1 fourth?
16.
1 eighth. 1 half of 1 eighth? 1 half of 1 16? Do you see how it's getting closer and closer and closer and closer and closer to 0? Does it ever touch 0? No, it always gets halfway closer. Does that make sense? Okay, cool. That's it. So just keep that concept in your head. That concludes the lesson.